welcome you all to session 6 of the chapter Units and Measurements. This session will be on significant figures and their importance. Let me begin this with an example. If you go to a bakery and ask him to give 250 grams of mixture, right? He puts the mixture in a plastic and he weighs. Will he give exactly 250? Not all the time. If it weighs 252 grams, then also he packs and he gives to you, right? If it weighs 254 grams, then also he will be giving you, right? If it weighs 256 grams, then also he will just pack and he will be giving to you. So how much of mixture did you ask him? You asked him 250 grams. But if it is any one of these weight also, he will be giving you the mixture. Means for him these two numbers are important, right? If it is 260 grams, then will he give to you? No. He removes the mixture and again he weighs and he will be giving you. Means for a person who is giving you the mixture in a bakery, for him these two are important digits. Okay, let me call these two digits are reliable digits. Reliable digits. For him 2 and 5 are reliable digits on which he can rely upon, important digits for him. But the third digit, this digit is uncertain. This digit is uncertain, right? So for him again these two are reliable digits and this is uncertain. If it is also 254 grams, he will be giving you, right? Means this third digit is an uncertain digit. So what are significant figures? Let me state that now here, right? So what are significant figures? Significant, the name itself says significant means important, right? So what are significant figures? Let me tell you. All reliable digits plus one uncertain digit are called, what we say here, significant figures. Are called significant figures. Let me tell you. So what are significant figures? These are all reliable digits plus one uncertain digit. This is first one uncertain digit. So how many significant figures are there here? In this there are 3 significant figures, these 2 reliable and this is uncertain, right? Okay, so what are significant figures? Significant figures are all reliable digits plus one uncertain digit, so are called as significant figures. Okay, now how to count those significant figures? Let us take some rules now here, right? Okay, rules to count significant figures. Rules to count significant figures. Okay, let us take some rules. Rules to count significant figures. Okay, what are these? Let us check it out. So what are the rules to count significant figures? Right? Okay, the first rule says that all non-zero digits are significant. Right? So which digits are significant? All non-zero digits in a number are significant. Right? If a number is given to you, you must be able to tell how many significant figures are there in that number now here, right? Okay. Now, if I am taking an example, let me take number this size and let me take significant figures. Significant figures. Right? Okay, this side now here. Right? Let me take number and significant figures. So the first rule says that all non-zero digits are significant. If there is a number like this, right? So 5678, right? If the number is like this, how many significant figures are there, right? Okay, significant figures. How many digits are the significant digits? So what does first rule says? All non-zero digits are significant, right? Except 0, all the numbers are significant, right? Okay, so 5, 6, 7, 8. So how many significant figures are there? 4, right? 4 significant figures are there in this number, right? Okay, do remember this, right? all non-zero digits are significant. So this is the first rule, right? Except 0, all the numbers are significant, right? From 1 to 9, all the numbers are significant now here, right? Okay, this is the first rule. All non-zero digits are significant. Then which number is remaining now here? Which digit is remaining? 0. Okay, let me speak about zeros now here, right? Okay, the second one is zeros in between non-zero numbers, non-zero digits. Okay, let me take like this. Zeros in between non-zero digits are what we say now here, significant. So do remember, zeros will be significant if they are in the between, right? Okay, zeros in between non-zero digits are significant. For example, if it is like this 5008, right? 5 and 8, of course they are significant. Now we have zeros. If zeros are in the middle, then they also become significant. So how many significant figures are there? Okay, let me take like this. Let me take 3 zeros and 8 like. Now how many significant figures are there? 1, 2, 3, 4, 5. So how many significant figures are there? 5. Because zeros will become significant if they are in between two non-zero digits, right? If they are in between two non-zero digits, zeros also become significant. Do remember this. Okay, now let me take terminal zeros. Okay, terminal zeros. Terminal zeros with decimal point are significant. Do understand this? Okay, we I told you about the middle zeros. Now I'm speaking about terminal zeros, means ending zeros, right? When will terminal zeros become significant? Terminal zeros will become significant if the number has a decimal point. For example, if I'm taking here, right? If I'm taking 5.700, if I'm taking like this 5.700, right? Okay, now what are these zeros? These are the terminal zeros, ending zeros. Okay, will they be significant? Okay, just check it out. Terminal zeros will be significant. Just check it out. Is there a decimal point? Right? If there is a decimal point, these zeros will become significant, right? So there are zeros. Just check it out in the number. Is there a decimal point? Yes. Means these numbers will become significant. So how many significant figures are there? 1, 2, 3, 4. So how many significant figures are there in this number? 4. Right? So zeros, of course, these 5 and 7, they are significant itself, right? Zeros, ending zeros will become significant if there is a decimal point in that number, right? Okay. Now the fourth rule says that terminal zeros without decimal point are non-significant, right? Terminal zeros without a decimal point are non-significant. Okay, let me write like this, the same number, 5700, 5700. I'm not taking any decimal point here, right? Okay, now how many significant figures are there? Okay, just check it out. Zeros are there at the end. Check. Is there a decimal point here there? No, there is no decimal point. Means these two zeros will not become significant now. How many significant figures are there? 5, 7. There are only 2 significant figures. These are not significant figures. So how many significant figures are there in this number? 2. Right? Terminal zeros will become significant if there is a decimal point. Terminal zeros are non-significant if there is no decimal point in that number. Means terminal zeros will become significant when there is a decimal point, right? Okay, the significance of a terminal zeros depends upon the decimal point in the number, right? If there is a decimal point, they become significant, they become important, right? If there is no decimal point, they are not significant, right? Okay, just I spoke about middle zeros, then I spoke about terminal zeros. Now I will be speaking about initial zeros. Okay, the fifth one is initial zeros. Initial zeros are non-significant. Initial zeros are non-significant. Okay, if zeros are at the initial, right? Okay, at the initial of the number now here, right? Okay, if they are at the initial place, then they are non-significant. Okay, the question is like this. See, if it is 0.0273, how many significant figures are there? Okay, these are at the beginning. If zeros are at the beginning, they are not significant at all, right? So these two are not significant. So how many significant figures are there? 1, 2, 3. How many significant figures are there? 3. Right? Simple. right? So these are some of the rules to count significant figures. Do you understand this, right? Okay, these are the 5 rules. Do remember the 5 rules, right? First, non-zero digits are significant. Second, right, so I will be speaking about zeros itself, right? Middle zeros, they are significant. Terminal zeros are significant if there is a decimal point. Terminal zeros are non-significant if there is no decimal point. Initial zeros are not significant at all, right? Okay, so these are the rules to count significant figures, and one example I have given to you now, right? Do remember, right? So you need to understand how actually we count significant figures now, right? Now let me take a note point now here, right? Orders of magnitudes. Orders of magnitude are not what we say here significant. Okay, orders of magnitude are not significant. So what are these orders of magnitude? Let us check it out. If the question is like this, 5.75 into 10 raised to 3, so this is called as order, right? So the orders of magnitude are not significant. So how many significant figures are there? 1, 2, 3. How many significant figures are there? 3 significant figures in this number, and this order is not significant, right? Do remember this, right? Okay, let me take another one example. 2.0020 into 10 raised to 2. How many significant figures are there? Okay, is it a significant figure? No, right? This is not a significant figure. Let me calculate how many significant figures are there, right? Okay, these two are significant. These are middle zeros. Of course, they are significant. Is this zero significant or not? Right, check. Is there a decimal point there? Right? Yes, there is a decimal point. If there is a decimal point, this also will become significant. So how many significant figures are there? 1, 2, 3, 4, 5. How many significant figures are there? 5 significant figures. Do remember, these orders of the magnitude are not significant. So this is a note point that you need to remember it. Okay. And another thing what you need to follow here is, if you change the unit, right? Okay, for example, one thing what you need to remember here is that whenever you change the units, right? Okay, let me tell you now here, while changing the units, significant figures must remain what we say here same. Do remember this. Whenever you change the unit, significant figures must remain the same. That is the rule now here, right? For example, if I want to calculate what is 5 kg, right, in terms of grams now here, right? This is 5 kg. How much grams now here? That is 5,000 what we say now here grams, right? Okay. How many significant figures are there here? So there is only one significant figure. How many significant figures are there here, right? Okay, there are terminal zeros. Will these terminal zeros become significant? No, because there is no decimal point. Means these are not significant. How many significants are there? 1, right? Here one significant figure, here also one significant figure, and this conversion is correct. Do remember this, right? Whenever you convert from one unit to another unit, keep in mind significant figures must remain the same. Right? Okay, let me take another one example. You'll come to know here, right? Okay, this conversion is okay now here. If the conversion is like this, 4.0 kilometer. Okay, what is 4.0 kilometer? Right? Is it equal to, right? Let me write down here. This is 4,000 meter. Is it correct? Let me check it out now here, right? 4 kilometer, 4.0 kilometer is equal to 4,000 meter. How many significant figures are there here? Let me check it out. How many significant figures? Will this zero become significant? Yes, because there is a decimal point. So how many significant figures are there? 2 significant figures. Here, how many significant figures are there? Right? Here there is no decimal point. Means these zeros will not become significant. Only one significant figure, and this conversion is wrong. Right? Okay. Do remember this. This conversion is wrong. 4.0 kilometer, you cannot write it as 4,000 meter, right? Because there is difference in significant figures, right? Okay, shall I write like this? This can be written as like this: 4.0 into 10 raised to what shall I write now here? Minus 3. What shall I take now here? Meter here, right? Okay, sorry, it is plus 3. So into 10 raised to plus 3 meter. Let us check it out. How many significant figures are there here? Only one. Okay, sorry. How many significant figures are there here? 2, because there is a decimal point here, right? How many significant figures are there in this number? This, it does not have any significant figure. How many significant figures are there? 2, means this conversion is correct, right? So do remember this. Whenever you convert from one unit to another unit, while changing the unit, significant figures must remain the same, right? Even you cannot write like this, 4 into 10 raised to 3, what we say here, meter. You cannot write like this, because how many significant figures are there here? 2. How many significant figure is there? Only 1. So this is not having any significant figures. So this way of writing is also wrong. Do understand this, right? Okay, this is correct. And let me conclude like this, right? Do remember, 4 kilometer is equal to 4,000 meter. Is it correct? Yes. Because how many significant figures are there? 1. Here also how many significant figures are there? Only 1 now here, right? This can also be written as 4 into 10 raised to 3 meter. Is it correct? Yes. How many significant figure is there? Only 1 here. It is not having significant figure, only 1. But if you are writing with 4.0 kilometer, right? If you are writing like this, you need to write like this, 4.0 into 10 raised to 3 meter. How many significant figures are there here? 2. How many significant figures are there? 2 now here, right? Do remember this, right? If it is like this, you need to convert like this itself, right? So whenever you convert from one unit to another unit, do remember significant figures must remain the same. Okay, let me take some more examples now here, right? Okay, come on, tell me. If it is like this, 2, 1, 5, 6, 7. How many significant figures are there? 1, 2, 3, 4, 5. 5 significant figures, because all are non-zero digits itself. If the question is like this, 2,000, 21,000, how many significant figures are there? Right? Okay, terminal zeros, will they be significant? Right? Just check it out. Is there a decimal point? No, there is no decimal point, so these will not become significant. How many significant figures are there? 2 significant figures in here. Right? Okay, for example, 7.80. How many significant figures are there? Okay, this 0 will become significant because there is a decimal point. How many significant figures are there? 3. 3 significant figures, right? If it is 8, like this, how many significant figures are there? Middle zeros, yes, they become significant, and therefore, how many significant figures are there now here? 5 significant figures, right? Okay, if it is like this, 0.080, okay, 854. How many significant figures are there? Right? Initial zeros, they are not significant at all. So 1, 2, 3. How many significant figures are there? 3 significant figures. Okay. Now, if it is like this, 0.080500. Okay. Just check it out. How many significant figures are there? Okay. First of all, let me check it out. 805. This is a this 0 is middle zero, it becomes significant. Terminal zeros, will they be significant? Yes. Why? Because there is a decimal point. Okay. 1, 2, 3, 4, 5, 6. Will these be significant figures? No. Right. So how many significant figures are there? 6 significant figures. Right. Okay. If at all it is 80,500. Right. How many significant figures are there here? So 1, 2, 3. These will not be significant because there is no decimal point. So how many significant figures are there? 3 significant figure. Right? Okay, let me write like this. 3 into 10 raised to 8. How many significant figures are there here? Right? So this will not be significant because orders of a magnitude are not significant. So how many significant figure is there now here? Only 1 significant figure. This is how we need to count, right? The number will be given. You need to identify how many significant figures are there. Now let us check it out. What are the applications of significant figures? Now let us see some applications of significant figures. Okay, arithmetic operations with the significant figures. Okay, we will be studying about arithmetic operations. What are these arithmetic operations? Addition, subtraction, multiplication and division, right? Okay, how actually the significant figures work in this arithmetic operations? Let us check it out. Okay, let me divide into 2 parts here. In the first part, let me take addition and subtraction. Addition and subtraction. Okay, let me take the first thing, that is addition and subtraction here, right? Okay, the final result the final result should have as many decimal places as are there in a number with least decimal places, Okay, let us check it out. Let me give an example. You'll come to know what actually I'm speaking about. Okay, when we add or subtract the numbers, how much decimal places we need to take? Okay, that we are considering. In addition and subtraction, the final result should have as many decimal places as are there in a number with least decimal places. I think you are aware of. If you take two numbers and multiply, in a calculator you will be getting a huge number. How much number we need to add? Where we need to stop? So to understand that, you need to understand about arithmetic operation with significant figures. Okay. First, let us understand about addition and subtraction. Okay, let me take one example here. There is a 1.23, 2.124, 3.135. Let me add these three, right? Okay, if I add these three, I will be getting with 5, 6, how much do you get now here? 8, 4, 3, 4, 5, 6. Okay, this much you got, right? Now, the question arises here is, how many decimal places we need to take? We need to, when we need to stop, where we need to stop now here, right? We need to stop at 6.4 or 6.48 or 6.46, 486, or we need to write all the digits, right? So, to understand that, we need to know this rule. The rule says that the final result in addition and subtraction should have as many decimal places as are there in a number with the least decimal places. Means this number should have decimal place which is similar to the number with the least decimal place. So first thing, we need to calculate how many decimal places these numbers are having, right? Okay, first number, it has 2 decimal places. These are nothing but decimal places, right? The places after the decimal point, right? How many decimal places this number has? 2 decimal places. 2 decimal places. Okay, how many decimal places this number has in here? 1, 2, 3. 3 decimal places, right? Okay, how many decimal places this number has? 1, 2, 3, 4. 4 decimal places, right? Okay, then what should be the result of addition of these 3 numbers? The addition of these 3 numbers, the result we should write in a such a way that 6 point. How many decimal places we need to take? You need to check it out. Which is the least decimal place? Least decimal place means this is the least decimal place. How much is the least decimal place? 2 decimal place means answer should have only 2 decimal places. Did you understand? Okay, whenever you add numbers, how many decimal places we need to keep? Where we need to stop? That you can understand by this rule, right? Once again, the rule says that final result of addition and subtraction should have as many decimal places as are there in a number with the least decimal places. What is the number with least decimal places? This is a number with least decimal places, and we need to stop. Okay, with 2 decimal places I need to stop. 6 point. 2 decimal placements, this is the 2 decimal place, right? So I need to stop till 8. Okay, whenever I need to stop till 8, right? So this process is called as a rounding off. I need to round off to 2 decimal places. Whenever you want to round off with the 2 decimal places, first you need to check it out. The third digit, right? If third digit is greater than 5, right? We will be learning about the rules of rounding off also, right? If the third digit is greater than 5, then you need to add 1 to it. So what is the answer now here? 6.49. How many decimal places it has? 2 decimal places, right? Do you understand? It has 2 decimal places, which is similar to the number with the least decimal places, right? So the answer is 6.49, right? I stopped till 2 decimal place. So this is the rule. Do you understand? Whenever you add or subtract, right, the numbers, the final result should have as many decimal places as are there in a number with the least decimal place. So this is the thing, with the least decimal place, right? Okay, do you remember this? If you want to subtract also, the same rule holds good, right? For example, if you want to subtract 6.589 minus 2.12, how much we need to write now here? This is 9, this is 6, this is 4, and this is 4. So what should be the result? The result should have decimal places which is having least decimal. How many decimal places it has? 1, 2, 3. 3 decimal places, right? Shall I write like this? 3 decimal. How many decimal places it has? 2 decimal places. Means the answer should have how many decimal places? Answer should have 2 decimal places, right? It should have 2 decimal places. Okay, first I need to write 4 point. How many decimal places it has? 2 decimal places. I need to write till 2. Since the third number is greater than 5 now here, I need to add 1 to it. So I will be getting with 4.47, and this is the result. This is how we apply, right? So whenever you add or subtract, see decimal places, right? Okay, this is the first rule, addition and subtraction. Let me go with the next, multiplication and division here, right? What we need to see whenever you multiply or divide the numbers. Okay, the next subheading is multiplication and division. Multiplication and division. Okay, let me take multiplication and division. The final result, the same thing. The final result should have as many significant figures. See here, final result should have as many significant figures as are there in a number, with least significant figures. With the least significant, what we say here, figures. Do remember, right? So in case of multiplication and division, what we need to see? Significant figures, right? Final result of multiplication and division should have as many significant figures as are there in a number with the least significant figures, right? Okay, so whenever you speak about addition and subtraction, go with the decimal places. Whenever you do multiplication or division, we need to go with the significant figures. 5.879 into, let me take now here, 4.65. okay, first of all let me multiply, right? If I multiply this, what do we get? Okay, let me check it out now here. If I multiply 5.879 into 4.68, you will be getting with 27.3373. 27.3373. If you do it with a calculator, you will be getting the numbers like this here, right? Okay, see here, 5.879 into 4.65. In calculator, you will be getting the numbers like this. If you multiply, you will be getting this number. Then how many decimal places you need to take, right? There is a rule when you multiply, right? So final result in multiplication should have as many significant figures as are there in a number with least significant figures. Now you need to check it out how many significant figures the number has. Okay, how many significant figures this number has? 1, 2, 3, 4. 4 significant figures. Why? Because you know that all non-zero digits are significant. How many significant figures this number has? 3 significant figures. So the answer should have how many significant figures? 3 significant figures. But how many significant figures you got? 1, 2, 3, 4, 5, 6, 7. But we need to reduce it into 3 significant figures. You need to write the result in a such a way that it has only 3 significant figures. Okay, where how many 3 significant figures means I need to stop till here. 27 point. I will be stopping at 3. Right? Okay, see the next number. There is 3. It is less than 5. If it is less than 5, keep that number as it is. So you will be getting 27.3. So how many significant figures it has? 3 significant figures. So this is the answer of this multiplication of these two numbers, right? So where we need to stop, how many numbers, how many digits we need to take, right? Whenever you get confused, go with this rule now here, right? So when addition and subtraction are there, go with the decimal places. Just see the decimal places and check it out which number has the least decimal place and stop there now here, right? Whenever you go with multiplication and division, don't see this decimal places, see significant figures, right? Which number has the least significant figure, go accordingly, right? The final result should have that many significant figures as the number with the least significant figure, right? Okay, so this was the arithmetic operations with significant figures, right? So now we will be learning how to round off the numbers, because we need to round off to certain decimal places, right? Let us check what are the rules for rounding off the numbers now. Now let us check what are the rules for rounding of the numbers, right? Okay, the first rule says that if a digit to be dropped, if a digit to be dropped is less than 5, less than 5, if a digit to be dropped is less than 5, then the preceding digit is left unchanged. This is the rule number 1, right? If a digit to be dropped is less than 5, then the preceding digit is left unchanged. Let me take an example. Let me take a number here, and here I will be rounding off, right? Let me take a round off. So till where I need to round off? Round off to 3 significant figures. Let me take like this, right? Okay, let me take the number 6.764, right? How many significant figures this number has? 4, right? So 1, 2, 3, 4. I need to round off till 3 significant figures. Means I need to remove this. I need to drop this number, right? Okay, the first rule says that if a digit to be dropped is less than 5, okay, is it less than 5? Yes, it is less than 5, then the preceding digit is left unchanged. What is the preceding digit? So this is the preceding digit and it is left unchanged. So what is the round of this number? 6.76. And how many significant figures this has? 3 significant figures. This is how, this is the first rule now, right? If the digit to be dropped is less than 5, keep the preceding digit as it is, right? Okay, the second rule says that if a digit to be dropped is greater than 5, what we need to do? Then the preceding digit is increased by 1 or raised by 1, we can say in that way, right? For example, if it is like this 6.768, right? So I need to round off to 3 significant figures, so I need to remove this. So this is the digit which is to be dropped. If the digit to be dropped is greater than 5, then the preceding digit is increased by 1. So this is the number which is to be dropped. So which is the preceding digit? 6. We need to add 1 to it. So what do you get here? 6.77, right? Just I added 1 to it. So if a digit to be dropped is less than 1, less than 5, keep the preceding digit as it is. If it is greater than 5, add 1 to the preceding digit. So these are the 2 rules. The next rule says what happens if the digit to be dropped is equal to 5. Okay, let us take, that is the third rule now, right? Okay, now third rule says like this: if a digit to be dropped, let me take here itself, third rule, it says that if a digit to be dropped is equal to 5, what we need to do, right? If it is equal to 5, then what we need to do? For example, it is like this: 6.745. The digit which is to be dropped is equal to 5. Then what is the rule? Let us check it out. If a digit to be dropped is equal to 5, then the preceding digit is increased by 1 if it is odd, right? Here, then the preceding digit is increased by 1 if it is odd now. Okay, this is not the case. Let me take if it is like this. Okay, now if a digit to be dropped is equal to 5, then the preceding digit is increased by 1 if it is odd. Okay, I am dropping this, right? See the preceding digit, is it even or odd? If it is odd, we need to increase it by 1. So what is that now here? 6.7 increased by 1, how much do we get now here? 6.74, right? So the preceding digit, if it is odd, then you need to add 1 to it. What we need to do if it is even? Let us check it out. And the preceding digit is left unchanged, if it is, what we say here, even. If it is even number, it is left unchanged, keep as it is, right? For example, it is 6.765. Okay, the number to be dropped is 5, right? So this is number to be dropped, right? See the preceding number, is it even or odd? If it is even, keep as it is. So 6.76, right? So this is rule number 1, this is rule number 2, and these two are the parts of rule number 3 here, right? Simple. If you want to round off a number to a specific significant figures or specific decimal places, you need to check it out which number you need to drop. If you need to drop a digit which is greater than 5, add 1 to the preceding digit. If it is less than 5, keep the preceding digit as it is. If it is equal to 5, then there are two cases. If preceding digit is even, keep as it is. If it is odd, add 1 to it. So these are the rules for rounding off the numbers, right? Okay, thank you.